Here's another work problem. We're going to do number 10 here, and this is kind of interesting. Juan takes 15 hours to do a job that his father can do in 6 hours, so we can figure out Juan's work rate and his father's work rate, but it says Juan works for 4 hours before his father joins him. So Juan's working alone, and then they're working together. How long will it take the two of them working together to finish the job? Okay, so let's take a look at this. So I drew my table again, except we've got a couple situations. We got Juan working alone, and then we got Juan working with his father, and the father working with Juan. So they're going to work together for the same amount of time, but Juan's going to work alone for 4 hours. So first of all, let's figure out their work rates. So Juan's work rate, it takes him 15 hours to do the whole job, so how much of the job will he do per hour? Or in 1 hour, he'll do 1/15 of the job. So 1/15 of the job per hour. And the father's work rate, it takes him 6 hours to do the job, so he'll do 1/6 per hour of the job. Of the job per hour. Now in 6 hours he would do 6/6 of the whole job. In 15 hours Juan would do 15/15 or the whole job, one whole job. Okay. So Juan's work rate's going to be, whether he's working alone or with his father, it's still 1/15. So his work rate will be 1/15. And this is when he works with his father, when, time. And the father's going to, his work rate's going to be 1/6. Now, how long does Juan work alone? We actually have a time that he works alone, and he works alone for 4 hours. Well, in 1 hour he does 1/15, 2 hours 2/15, 3 hours 3/15. So in 4 hours he's going to do 4/15. So the time that he's going to be working would be 4 hours. And if we multiply that across, he's already done 4/15 of the job. These usually add down. A lot of these tables we use, the columns add down to give us an equation. Sometimes two columns give us two equations. Now, they're going to work together, and that's what we want to find out. How long will it take the two of them working together to finish the job? So we'll call that X hours, so they're going to work X hours together. And in X hours, we know in 4 hours, Juan does 4/15, so in X hours, he does X/15 of the job. And in X hours, his father does X/6 of the job. And all these fractional parts add up to be the whole job, one whole job. So there's your equation. 4 over 15 plus X over 15 plus X over 6 equals one job. Now we got to figure out what the LCD is. Now, usually when you're a little person and you're learning fractions and stuff, what your teachers should tell you when you have several denominators and you want to find the least common denominator, always try the biggest one, and then see if the other denominators divide into that. The biggest one is 15. 15 goes into 15, but 6 doesn't go into 15. And then try 2 times the biggest one, then 3 times and 4 times, until you find one that works. Well, what's 2 times 15? 30. Does 6 go into 30? Yes. So my LCD is 30. So I'm going to multiply every term by 30. On both sides of the equation, every term by the LCD. Now 15 goes into 30 twice. 2 times 4 is 8. Fifteen goes into 30 twice. 2 times X is 2X. And 6 goes into 35 times, so 5 times X is 5X. And then 1 times 30 is 30. We can add these up. So 2x plus 5x is 7x. And I'll subtract 8 from both sides, so I'll have 22. Subtract 8 from both sides, so 30 minus 8 is 22, and 2x plus 5x is 7x. Then if I divide both sides by 7, x equals 22 over 7. And 7 goes into 22 3 times and 1 left over, so 3 and 1/7 hours. And 7 doesn't divide evenly into 60, so it'd be hard to convert this into minutes, so we could leave it like that. And you could check it, but it would be a little challenging with the fractions to check it, but it would check out. You'd have 4/15 plus 3 and 1/7 15 plus 3 and 1/7 6, and that should add up to be 1. So there you go. So the table makes everything a lot easier to keep track of. So give yourself plenty of room, use a ruler, make your tables nice and neat, and I think it will pay off.